Good morning, friends and fielders, Filecoin builders, yeah, right. I'm Ali, I'm a DevRel engineer at the Filecoin Foundation, and I've also been working with Bacalhau, our team, for the last 6 months as well. And I'm happy to be joining you all in Boston today, and also joining FVM dev advocate Zach Ayesh for a duet on compute at Filecoin that I like to call the Ali to Zach, or A to Z of compute. Yeah, I won't give up my day job. So a quick agenda for everyone. I'm going to get into the why we're doing this. Why is this important for Filecoin? Why is this important technology in general? Then we're going to have an introduction to FVM from Zach, as well as a demo of deploying a market actor smart contract. And then I'm going to get into introducing Bacalhau, and I'm going to do a quick demo of calling Bacalhau from a smart contract with a project we have called Lilypad. So quick introduction. This quote from Juan Benet, the founder of Protocol Labs and Filecoin, really sums up one of the reasons I went into tech originally, and that's because of just how fundamentally innovation and technological advancement can change and improve our human lives. So tech creates these new frontiers for us, like the ability to take photos of black holes, build sustainable energy sources, and it can also help us solve increasingly complex problems with faster and more powerful computing, crunching over more and more stored and available data. And it has this capability to enable changes, not just in our daily lives for fun and convenience, but also in the fabric of society itself, because those daily changes really add up. If you think about the printing press, washing machines, things like that really changed kind of how we operate as society, and of course more recent ones like the internet. So it's also why it's so essential that we're creating a future for the underlying technology that we use daily to provide this open and fair web that protects our human rights and helps us move forward in a more egalitarian way. So, as you would all know, being that you're attending a conference on computing over it, data is an absolutely essential part of our lives, so enabling these distributed storage and compute mechanisms for data is part of the fundamental mission we're working on at Filecoin and Protocol Labs. So building that tech to enable open, scalable and distributed data systems, and allowing for open innovation to provide the base infrastructure needed for this open web vision. So in practice, that means it's not only essential that we create the distributed storage and retrieval network that enables that data sovereignty, which we're doing with Filecoin, but as well as and providing the content verification system with IPFS, but it also means enabling computation of data in a way that aligns with this open web mission. So it's summed up pretty much by this slide on the 4 pillars of a decentralized internet as we see it at Filecoin. And we think about some of the data stored in the Filecoin ecosystem, climate change data, scientific data, all sorts of open education libraries, public and government data sets. It kind of gives an even better picture of just how essential it is that this data is open and accessible, and we're making use of this data in collaborative ways. And it's also never been more relevant or important than today, I think, with AI applications exploding into mainstream use. So with programmable applications enabled by FVM and with verifiable Bacalhau peer-to-peer data computation, we're kind of enabling tokenized data marketplaces, open source machine learning algorithms potentially, and other things with many more applications. So I'm going to hand over to Zach here, though, to chat about the Filecoin virtual machine and FVM. Woo, Zach.
Thank you. Hey, everyone. My name is Zach Ayesh. I am a developer advocate with the Filecoin virtual machine team. So I basically help developers build on top of the Filecoin virtual machine. I've been in the Web3 space for about 6 years now, and I'm really fascinated and interested in decentralized infrastructure. I think there's still a lot of cool things we can do at the infrastructure level, which is what drew me to Filecoin, decentralized storage, and specifically the FVM, because I think it's a really cool tool that will empower a lot of things. And we're going to talk about what it will empower in a second. So if you're not familiar, the Filecoin virtual machine brings programmability to the Filecoin blockchain. So if you're familiar with a blockchain like Ethereum or Polygon, they have this concept of smart contracts, so they run distributed code. And Filecoin originally was built for the ground up for decentralized storage. So connecting to storage providers, storing data, and having the storage providers prove that they were storing this data onto the Filecoin blockchain. But there was no virtual machine on top of it, so that's what you would do with Filecoin. Now we have the Filecoin virtual machine, and we'll get into the architecture a little bit. It's written in WASM, but it's actually built in a way to actually allow any other kind of runtime to be built on top of it, right? So it kind of works like a hypervisor or virtual machine on your computer, where like maybe you're running a Windows machine and you open up a virtual machine for Linux or Mac OS. And so it's built in WASM, but the first runtime we actually have running on there is the FEVM, or the Filecoin Ethereum virtual machine, right? And this allows us to take advantage of all existing tooling around Solidity, EVM bytecode, Viper, Hardhat, Remix, all of these awesome tools that a lot of smart contract developers are already used to using. And keep your eye out in the future for other runtimes down the line. The next one is definitely going to be a native WASM executor, which will be a lot cheaper in gas. But we wanted to kind of bootstrap the network with Solidity code first. So you're going to hear these terms like we're at the COD Summit, Compute Over Data Summit. But you'll also hear me talk about compute over state, right? And this is actually the level of the FVM. And what do we mean by compute over state, right? So in this diagram here, you see the L0. This is kind of what Filecoin was made for, is decentralized storage, archival storage. And then at this kind of L1 level, we have the smart contracts. This is computation over state, where smart contracts live. And on top of that, we have compute over data, and this is where a project like Bacalhau lives. So it's kind of orchestrated from the state on chain, but it's actually off of the Filecoin blockchain, and then it gets verified on chain. So another way to think about this is, we have these concept of storage deals on Filecoin that don't exist on any other blockchain, really. And the cool innovation of the FVM compared to other smart contracting chains is that you can make smart contracts, you can build logic around these storage deals, right? And you can, for the first time, have programmable storage primitives in a blockchain, which hasn't been done in any blockchain before that I am aware of. Right, so let's look at storage deals a little bit and make those a little real for you. So I'm going to try to go, and bear with me as I try to navigate here. See if the internet will load. So I'm going to, PhilFox right here. So PhilFox is a blockchain explorer. If you're familiar with blockchain explorers, it's like Etherscan for Ethereum. And we are on the hyperspace testnet. So that's one of the primary testnets for Filecoin. It is being deprecated in a bit for a more stable testnet called Calibration Net. So I should tell you, if you're doing your work on hyperspace, prepare for Calibration Net. We're moving all the docs over there. It'll have all the same features. It'll be a pretty easy switch. But what we're looking at here is, if you go here in this tab, blockchain, you'll see a tab called deal list. I'll click on that. And you'll see a bunch of these storage deals. These are the metadata. This is the state that we're talking about with compute over state, right? Each of these represents data stored in a storage provider somewhere off of the Filecoin blockchain, but they're proving that they have the data in this deal stored using zero-knowledge proofs, right? So let's click in a deal. And you'll see, every deal has an ID, it has a date, a block number, and importantly, a PCID. And we'll talk about what a PCID is in a bit. And you'll see that the client and the provider have to put up a collateral. This is to prove for the client that they can pay for the service that they're about to get from the storage providers to store their data. And the provider has to put up collateral to prove that they have stake in the game, right? So they have to make these zero-knowledge proofs to prove that they have the data stored. And if they can't make those proofs, if they can't produce them, they get slashed, right? So that PCID that I showed you earlier, a mental model you can use of it is kind of like a hash that represents all of the data being stored in that deal. It's a little bit more complex than that, but that's essentially what it kind of comes down to. Really, you can see in this diagram that you have to prepare your files into a special format called a .car file, and produce this IPLD DAG, or kind of looks basically a Merkle tree, right? If you're familiar with like how Ethereum does state. And at the top, you get this COMP or PCID that kind of represents all of this data. Right, so originally, this is the flow for how you had to make deals on Filecoin. It was a long process with many steps. Especially for the user, you basically had to find a storage provider, figure out what their going rates were. If you didn't agree with that, maybe negotiate with that storage provider. So you'd have to go on like maybe a marketplace or something. Then, once you kind of had an agreement with them that you think would work, you would send them a signed deal proposal with your key. It would be signed. They would review it, and if they agree with it, you would give them the data to store, and they would have to call a function in the Filecoin APIs to publish that storage deal and actually start activating the deal on chain, right? So kind of a cumbersome process. But, went to a slide a little too early there, but you'll see going forward, the FVM has allowed us to make this a lot easier and programmatic, right? Because that's the whole point of the FVM. We want to make this automatic, programmatic, and make it easier for users to program logic around making deals on the Filecoin blockchain. And so that's one use case. This is a slide of all the different kinds of use cases that we imagine being used on the FVM. And as you see right there in the center, we have decentralized verifiable computation, which is where Bacalhau comes in, and all of the other awesome COD projects that are around here. Other projects, because we'll go into a little bit more, Ali will go into more detail about the verifiable computation in a bit, but another big one we're seeing is data DAOs. So data DAOs are this concept of, a DAO, a decentralized autonomous organization. And instead of having a single user in charge of what data is stored on the Filecoin, you can program these DAOs, these data DAOs, to kind of manage the data that's being stored in the Filecoin blockchain, right? Like voting on what they want stored, putting up bounties for what they want stored, all kinds of things there. And other things like perpetual storage. That's a other cool application that FVM allows. Could be in conjunction with the DAO, right? Like the DAO could say, hey, we want to store this data continuously because a deal does have a start and an end. And when the deal comes to an end, the DAO could vote to renew that deal. And if it's some very important like scientific data or just something very important to the DAO, they can vote to renew it continuously and crowdfund for that. All right, so I'm going to make FVM like a little real for y'all, right? So like we're talking about all of this. How does it work? Like let's deploy a smart contract. I'm going to deploy a simple smart contract that reads data from the market API, right? So all of the deals on Filecoin can be retrieved through traditionally what's called the market API. Now there's what we call an actor or smart contract, an inbuilt actor that Solidity smart contracts can access to get this data, right? So this isn't something you can do on Ethereum. We have very specialized Solidity libraries called filecoin.sol. These were built by our friends at a team called Zondax. Did an excellent job. And basically these contracts interface in between the inbuilt actors, the traditional APIs on Filecoin, and the Solidity world. So you can bring all that data in to your Solidity smart contracts. So I'll just give you a little preview of what's going on in this contract. So we have this hard hat kit. If you're more attuned to developing locally and you're already familiar with the Solidity world, this has a bunch of pre-built contracts, including the one I'm about to show you in it, and a bunch of configurations for automatically working with Filecoin. But essentially, you'll see here, this contract inherits these Zondax Filecoin Solidity contracts, right? Specifically the market API I was just talking about. And all this contract does is it has a bunch of state variables. These are the deal information, and a bunch of functions to call the market API and store them in state so you can write logic around them. You'll actually see here there's another more complex contract called the deal rewarder contract right here. And this actually allows people to put up a bounty, and they can call a function to retrieve a deal. If it's the deal for the bounty that they propose, like, hey, we want this data with this PCID, it's this size, and that deal is made on chain, this contract will pull that data, see that the data that's stored on chain matches what the bounty is, and pay out whoever made that deal, right? So you can put up a bounty for any kind of data. Just to give you an idea of the kind of logic you can build around these storage deals on the FVM. Right, so let's go ahead. I already have Remix open. We're going to go there. And, I'm going to go ahead and mirror my screen so I can actually do this properly. All right, so Remix, if you're not familiar, is an online IDE, integrated development environment, for basically quickly testing and developing smart contracts. It's typically used when you're just trying to mess around, fiddle around with smart contracts, and get started in smart contract development. Usually, when you're really building a project, you'll eventually move on to something like Hard Hat or Foundry, those local development environments. But you'll see here, this is that Filecoin market consumer contract I showed you from the GitHub. It's already preloaded in here. So what we will do is we will come here to the Solidity compiler. It's already on autocompile, so it's compiled, but you would compile your file right here. And we can go to the bottom tab. And you're going to want to switch from Remix VM to injected provider MetaMask. So MetaMask is one of the biggest Ethereum wallets, and since the FEVM is completely EVM compatible, it totally works with Filecoin. You can go to chainlist.org to add all of the Filecoin networks into MetaMask, and so now Remix knows to go through MetaMask, and my MetaMask is set to the hyperspace testnet. Future to be calibration net. And we will just hit deploy. It's showing my right address. We will hit deploy, confirm. And now, the Filecoin block times are about 30 seconds on average, but Filecoin has this thing called deferred execution. So even after your transaction is included in the block, it takes about another 30 seconds, another block, for that transaction to be actually executed on the state, right? So we're not actually going to sit here and wait for this contract to be deployed. I put in my notes a pre-deployed contract right here. And you can actually just load the contract from this address. It'll happen instantly because all it needs is what's called the ABI, or the interface of the contract, and it'll just appear right here, right? And so you'll see all the functions that I have here. Store all, which just calls all the other functions, and every store function for every specific piece of information you might want for a deal. Now, I've already stored information for a deal from 1760, but if you wanted to, you would just have to put in the deal ID, 1760, click store all, MetaMask will come up, and store that information. We don't actually have to do that right now since I've already stored it. But if we go through here and look at like the deal commitment is the PCID there that you see in the bytes and the size of the data. So PCIDs, I think, are base 64. You'll see them encoded in that. Ethereum uses bytes, hex bytes, as their bytes encoding. So it's translated right there into hex. But it is that same deal PCID. You have the deal label, which would be the CID that you would see on something like IPFS, because they are different due to how the file is compressed into Filecoin. And the deal term, how long the deal is meant to start and end. And yeah, so you can write all kinds of cool logic around that to enable those applications. And that is one thing. So we have also the Filecoin client contract, which again is there to act as a deal-making contract if you want to actually make the deals. So I was showing you how to retrieve deal information, but that could be a whole nother like 45 to an hour demo. So we're not going to go through that today. So some references for the resources for the FVM, if you're interested in building or don't already know about these. This QR code here will take you to a link tree that my colleague Sarah put together. Has a bunch of awesome resources, hackathon cheat sheets, basically everything you need to go to. These are some of the kits we have. So I have 2 starter kits here, the hard hat kit and the foundry kit, depending on how you want to develop locally. And a brand new kit, a COD starter kit, which basically just wraps Lilypad, which Ali will go over in a bit. But we hope to flesh this out more and add more COD examples and other things to it. So yeah, that is just the introduction to FVM and FEVM. If you have any questions, please feel free to reach out to me. My team is also over there of other developer advocates, Sarah, Matt, and Longfei. So feel free to ask them any questions too. And with that, I'll let Ali come on stage and demonstrate how COD and Bacalhau integrate with the FVM. So thank you, everyone.
So just briefly, because I think folks here have probably already heard about it, Bacalhau is a peer-to-peer network of nodes that enable users to run Docker containers or WebAssembly images as tasks against data that is stored in IPFS and in future, hopefully, Filecoin as well, and provides this platform for public, transparent, and verifiable computation. So it was originally conceived to bring useful compute resources to this data stored on IPFS and the Filecoin network, bringing these same benefits of like open collaboration on data sets to generic compute tasks. So let's talk about now how Bacalhau and FVM can work together. So we saw this slide a little earlier. Zach put it up. So just taking it back to the architecture view, as we said, Filecoin can kind of be considered the layer 0, this really robust internet scale storage network. And then we've layered over FVM, bringing like these layer 1 capabilities to the Filecoin stack and making it really easy to do that compute over state. And Bacalhau can bring the additional capability for off-chain verifiable compute tasks on large data to the network. So this kind of makes for some really powerful tooling to enable this new open web that I was talking about earlier. And I'll come back to Lilypad in a second. So quick recap on the differences here. FVM enables computation over state, bringing those programmable applications and logic to the Filecoin chain, and Bacalhau enables complex off-chain computations over data, which is something that no blockchain really does well because, it's decentralized by nature. And that brings those inherent values, though, with it from IPFS, Filecoin, and the Web3 world as well. So Project Lilypad is one of the ways we're enabling connecting this compute over state, FVM, with compute over data, or Bacalhau. So enabling you to call Bacalhau jobs directly from your smart contracts, basically. So why are we doing this? Well, outside of the overall Filecoin vision I introduced earlier, I think Peter Wang from Anaconda said it best yesterday. He was one of the keynote speakers yesterday. If you didn't see that talk, I really recommend looking it up if you're at all interested in AI, because he did a really great job of explaining, why we really need to be invested as a community in building these really community-orientated systems for data rights in AI. So definitely check that one out if you didn't. And as Patrick Collins, who probably a lot of people in Web3 would have heard of, so succinctly put it as well, we need this credible, neutral technology of Web3. And there's many more voices seeing the need for blockchain and AI to work together for a better outcome. And side point, I don't know if anyone's read this recent leaked Google document, who knows if it really is, that it doesn't have a moat. It's basically advocating that open source is winning kind of the AI race and is doing it better than these commercial entities, which to me was really great to hear, to be honest. So the team has built this proof of concept, Project Lilypad, for making it easy to use Bacalhau jobs from an FVM smart contract using these contracts. Basically, as a base layer, Lilypad acts as a bridge for calling any Bacalhau job and receiving those results from Bacalhau, which come back as IPFS CIDs, directly from a Solidity smart contract. So a user contract that you would write in Solidity implements the Lilypad caller interface, and to call a job, they just call a function with the spec for the job, so like a Docker image spec. To call that, they call a function in the Lilypad events contract. So that will trigger our Lilypad bridge daemon to then go ahead and send this job off to Bacalhau for computation, and then it returns the results back as soon as it's finished. So once the job is complete, it goes back to the original user contract that was built in Solidity. So you'll get the results directly back to your state. So one of the example user contracts in the Lilypad repo is this Stable Diffusion example, which I'll kind of go through now. Though as an aside, if you're interested in actually building the AI script, the Python script yourself for this text-to-image Stable Diffusion example, there's a full walkthrough on that on the Bacalhau docs as well. So if that's a side you're interested in, feel free to go and check that out. And because we all know how well live coding goes on stage, I've got a video instead. So to call, hopefully this loads. Yay, internet. All right, so I've just loaded this up on Remix, which Zach was showing you before. So to call a Bacalhau job on FVM, you create a smart contract that implements that Lilypad caller interface, and that interacts with our Lilypad. This is the back end, just showing you kind of the bridge daemon where the Bacalhau job was running. Sorry, that was pretty quick, but it will show you like there's nothing there, then all of a sudden an event comes through, Bacalhau runs that job and then sends it back as a CID, and there's my Stable Diffusion result right there. So this is the overall folder it comes back in, and then you can look up the kind of output of that job, which in this case was an image. So you can make all sorts of cool things with this. I initially made this NFT app, but I've gone further than that since then. And we've actually made a user-facing app called Waterlily. We've taken this kind of further. It does use Lilypad to do this. So Waterlily.ai is kind of this first of its kind user-facing app that's aiming to provide a more equitable new paradigm in generative AI. So we're kind of leveraging the benefits of having a blockchain like FVM to enable automation of payments to artists on this chain. So what happens is, as a user, you would go in, you would type in kind of, whatever prompt you want for your Stable Diffusion image. Then you'll choose one of the artists that has uploaded their work to the chain and had a unique model trained on their artwork. And you pay a small fee in order to generate, you'll get 4 images back on Waterlily. And then that fee, outside of, the fees for running on the chain, Bacalhau doesn't take any money, goes directly to the original artist. Or in the case of public artworks, we send it to a art foundation charity, so grey area at the moment. So yeah, we've taken the concept a little bit further, and this is kind of one of the cool things you could do with like blockchain and AI with Lilypad, we think. We've got a heap more use cases in the pipeline that we're thinking about as well, things like enabling storage deals or easier storage deals, like, yeah, I was looking for Zach, where'd he go? Yeah, so things like that, or integrating with some of our dev tooling, enabling kind of an Oracle-like service. It wouldn't exactly be an Oracle, but an Oracle-like service. A lot more AI and ML use cases, and then like kind of wider Web3 use cases. Of course, the roadmap, we want community input on. This is how we make a better future by, getting what people actually want to build out from them. So feel free to let us know if you have any ideas on what you'd want to build or use. But we've got some use cases in the pipeline and like kind of a roadmap of where we're going to go from here. If you do want to hear more, get in touch with us, usual things. And we're having some really cool discussions over in the Bacalhau Slack about where, decentralized AI and ML could go as well. So if you're interested in just like lurking or participating in that, we'd love to hear from you as well. Cool, that's it. Thank you. Any questions or comments? Happy to answer otherwise. Or for Zach as well. Cool. Yep.
FVM, I think there was some amount of constraints in computing, so Bacalhau opens that up in
Yep.
terms of compute time and resources. Is there any kind of constraint there in looking at kind of running Stable Diffusion and things in terms of, or is it just pay for what you need, or what is the sort of capacity today?
Yeah, so currently the public Bacalhau network is free. We don't have a pricing model on it, so we're running this as a public good at the moment. In future, we're developing the game theory around that to enable, other nodes joining the network, like having untrusted nodes be on the network and get paid for jobs that get run. Also, obviously then we'll have a pricing model. I think probably the best way to go is everything's in WASM code then. New jobs will have to be WASM code, so you can calculate that kind of gas that it would cost to run that job. But yeah, that's kind of where we're heading in the future and what we're planning out right now. So that's definitely what we want to do with the network.
And is there a difference in fetching data from IPFS or Filecoin in terms of like egress or data fees or where these nodes run?
Yeah, so it's an edge compute network. So we currently can't fetch from Filecoin, though that's part of our roadmap in the future. We want to investigate how easy that is to do and try and enable that in one way or the other, whether that's just through current tools we already have or whether that's natively, which would be amazing. But at the moment, everything comes out of IPFS for the Web3 side. Otherwise, you can actually run on AWS buckets and things like that if you're not that you don't really care about where it is. But yeah, definitely it runs on IPFS as well at the moment. Egress, I couldn't tell you, but probably one of our engineers can. Who I can find for you later. Or there's one right there, actually.
Yeah, it's just such an interesting idea of saying, well, data's somewhere, compute somewhere, they're all computing in decentralized, there's still bits flying around, and you
Yep.
can kind of rethink of geography again.
Yeah, totally. Like, where is the edge in this case? Yeah. Yeah, totally. So, yeah, definitely great question. I'd love to chat more about that later, but cool. All right, Zach, do you want to reclaim your laptop? Thank you, everyone. I think we finished maybe a little early, did we? I thought it would be so late.